So Q equals M times C times delta T. So Q is the heat measured in joules. M is the mass, it's measured in grams. C is the specific heat capacity. And it's measured in joules per gram degree Celsius. And then this triangle T, remember that triangle just means the final temperature minus the initial temperature. So we say the TF, which is final, minus TI, which is initial. And this is measured in degrees Celsius. So we can calculate the amount of heat if we know the mass of a substance, we know its specific heat capacity, and we know the change in temperature. We're going to use both rearrangements of this equation in today's lab. We're simply trying to say how much heat is going to be either absorbed or given off. Sometimes you're going to get a positive amount of heat. And if you get a positive amount of heat, that just means you have an endothermic process. And an endothermic process, remember it's saying that you're going to be gaining some heat. Your system is going to be gaining some heat. On the other hand, sometimes when you do this calculation and solve for the amount of heat, it's going to give you a negative number. And it doesn't mean you have a negative amount of heat. It simply just means that this is an exothermic process and your system is losing heat. And we're going to see that in today's lab. We're going to be losing some heat. We're going to be gaining. We're going to have negative and positive numbers. And so when you see this negative number, it's not saying you have a negative amount of heat, just like you can't have a negative amount of mass. You're just going to end up saying, it's telling you which direction it's flowing. It's kind of like saying, is it flowing to the left or is it flowing to the right? We can assume that the right is positive and the left is negative. And it's saying, is it flowing out of the system or is it flowing into the system? All right, so let's go ahead and do some example problems. And let's just do a few and then we can go ahead and get started on the lab. So I want you guys to pull up this worksheet, the chapter 3 worksheet. This is the second page. I just skipped to the second page of it. Looks like this.
What is it, Professor?
All the worksheets that I post are going to be under contents and then lecture worksheets. And then you just go to the chapter that we're in. So we're in chapter 3. So if you go to chapter 3 under lecture worksheets, it's going to be the only worksheet that we have. I think the other one's just like a PDF of the states of solids, but the first page looks like this when you click on it. I'm skipping to the second page. And go ahead and give me a thumbs up once you have it. Okay, I see most of us have it. All right, great. Okay, so let's do a few of these together. I'm gonna do the first one with you guys. We're gonna read through it and then we're gonna do it together. And then I'll give you a few minutes to work on the other ones. So the first question says, the first questions, I'm gonna let you guys answer those on your own, but if we go through the review that we just did and try to answer these calculations, the first question says, perform calculations using this equation. It even gives you the equation. It says gold has a specific heat of 0.129 joules per gram degree Celsius. How many joules of heat energy are required to raise the temperature of 15 grams of gold from 22 degrees Celsius to 85 degrees Celsius? So this is typically what a problem looks like. In this case, can anyone tell me what variable we're solving for in this problem? What letter are we looking for? Out of these letters, which one are we trying to find? Say it again. Said M?
Yeah.
So remember, M stands for mass.
Oh, sorry.
That's okay.
Q. Heat.
Yeah, we're looking for
Yeah.
Q. Great, but
This is
just
measured in joules.
M stands for mass, and mass is going to be given in grams. If we're looking for how many joules, that means we're looking for the heat, and that's the letter Q. So that's why I wrote down what each unit is, so we don't get confused. So in this case, we're looking for the amount of joules. It says the amount of joules of heat energy. So that just simply says, how much heat are we looking for? How much heat? So we have the equation, Q equals MC delta T. So then we just plug in everything, and it says, okay, if you want to raise the temperature of 15 grams is my mass, because gram stands for mass. 15 grams. My specific heat capacity, it tells us right here, specific heat is 0.129. So my C is 0.129 joules per gram degree Celsius. And then my change in temperature, I'm going to put it in parentheses. My change in temperature, tell me what my final temperature is, guys. Can anyone tell me that?
85 degrees.
85 degrees Celsius. And that means my initial temperature is going to be 22 degrees Celsius. So in this case, this is all I need to solve for the problem. What we really have to focus on now is calculating our answer to the correct amount of significant figures. So I would say the first step is parentheses, because I'm going to go in the order of operation. So my parentheses say 85 minus 22. What's the rule for significant figures in adding and subtracting?
Least decimals.
Least decimal. So what's the least amount of decimal?
None.
None. So 85 minus 22, you guys pull out your calculator. If you don't have it out, can someone tell me what that is?
63.
63.
All right, perfect. 63. So we know this is 63 degrees Celsius. Now I'm going to say 15 times 0.129 times 63. How many sig figs should I have in my answer, guys?
2.
Two. I should have 2 sig figs because the least amount of sig figs is 2 sig figs. Do we see that?
Yes.
All right, so we're not going to count the sig figs in the specific heat capacity. We're counting the sig figs in the grams and the temperature change. So you guys give me this answer rounded to 2 sig figs. Let's see if we can all get the
41.
same. What do we say?
I said 41.
41?
Yeah.
If we do 15 times 1.129 times,
Oh, I'm sorry. I'm sorry.
12.
Something 121.
1
All
point
right.
times 10 to the second.
All right. So it's not like we're getting the same number in the calculator, at least. That's good. But let's look at this again. All right, this is what I got in my calculator, right? Is this what you guys got?
Yep.
Yes.
So then we said 2 sig figs. We got to get this down, guys. I heard a couple of you guys say 12. We can't say 12 is our answer because 12 is not the same thing as 120. That's a factor of 10 off. So when we say our 2 sig figs, you're right. We're going to count the 1 and the 2, but then we look to the right. We round it down because it's the 1. So we're going to say 120. You guys see that?
Yeah.
So our answer altogether should be 120 and 120 what? What's the unit?
Joules.
Joules. I heard someone else say it in scientific notation. That works as well. We could say 1.2 times 10 to the power of 2 joules.
So it doesn't matter if there's a 9 after the decimal or no?
If there's a what after the decimal?
A 9, like to round?
No, it does not matter either because you only need 2 sig figs.
Okay.
Even if you rounded this to 122 with 2 sig figs, it's still just 120.
Okay.
Question.
What's
So
that?
could it be 12.0?
Yeah, but most likely that's not going to be given as an answer or accepted because that's not scientific notation. If you say 12.0 times 10 to the 1, that'll work, but that's not going to be given as an answer. Maybe if we were in class and I was grading and I could see your work and come write it, give you some credit like that. But on like a multiple choice quiz, you're not going to see 12.0. Well, 12.0 is incorrect because it's just the number 12. We're trying to get to 120, and they're two different numbers. You'd have to multiply 12 times 10 to get to 120.
All right.
Okay? It's a common mistake you guys make when you're trying to get to 2 sig figs or a lesser number of sig figs. You just want to cut the number off, but you can't cut that number off. You have to at least go to the decimal and make sure you have your zeros in as your place values. All right. With that said, let's go ahead. You guys do 2 and 3, and let's make sure we can get the same answer. You guys go ahead and try to set up number 2 and number 3. And let me know if you have any questions. So endothermic or exothermic down here, we need to go ahead and say whether this process is endothermic or exothermic. So if you guys want to guess what this process would be, what do you think it is?
Endothermic,
Yes, why would it be endothermic?
because it's a positive answer.
Exactly. Okay, it's just saying that this gold is absorbing some heat. It's gaining some heat. That's all that's saying. So the gold is just going to be absorbing some heat, and it's a positive number. That's all that really means. So for each answer, we just want to know, is it an endothermic or exothermic process? And we know because the positive sign means endothermic, the negative sign means exothermic.
So we don't have to solve anything, these questions.
Yeah, for endothermic or exothermic. You would have to get the answer to know, for instance, this one says it absorbs 100 joules. So when it's saying it absorbs 1,000 joules, it's already telling you that it's endothermic because it's absorbing something.
Mhm.
All right, so we're on number 2 now, and it says we have this unknown substance that has a mass of 1,000 grams. Okay, so we know automatically that's our mass. It absorbs 1,000 joules. So what's this 1,000 joules? What variable is this?
Heat.
That's our heat. So that's what letter?
Q.
Our Q, okay, while undergoing a temperature increase of 15 degrees Celsius, and we know that this is going to be our change in temperature. The question says, what is the specific heat of the substance? So now, what are we solving for, guys?
C.
We're solving for C, and since we're solving for C, I'm going to use this rearrangement of C that says C equals Q over M delta T. So in this case, you guys tell me my Q was 1,000 joules. This is a decimal behind it, so 1,000 joules. My mass is 100 grams. And then my change in temperature is 15 degrees Celsius. So we're just gonna put this in the calculator. There's no addition and subtraction. This is all multiplication and division. How many sig figs do you guys think I need in my answer?
3,
2. 2.
2,
Why are we saying 2?
Oh, I'm sorry, 3.
3.
This 15 has 3 sig figs, 1, 2, 3. Remember the 0, if there's a decimal there, that 0 is significant. The only time your zeros aren't really significant are when the zeros are at the front of a number. As long as there's a decimal there, or if you have zeros at the end of a number with no decimals. So let's put this in our calculator. And we're just simply gonna say 1,000 divided by 100. And when we divide these two numbers, guys, remember we need to put it in parentheses so our calculator doesn't get confused. So it's simply like saying that 100 times 15. So we're gonna put it in our calculator like this. And we get 0.6666667. You guys told me I needed 3 sig figs. With 3 sig figs, what should this answer be?
0.666.
0.667.
0.667. Remember to round. So we're gonna say 1, 2, 3. We look to the right, it's still another 6. We're gonna round this up to 7. So 0.667. And the units are gonna be joules per gram degrees Celsius.
Professor,
Yep.
so what numbers do we look to determine our sig figs? Because you said we had, because that's what confuses me the most. It's always like I can know how to set it up. It's just the significant figures that messes me up at the end. Because
Okay.
we're
Good
looking at 1,000 over 100.0 grams. Like how do we have? There's one sig fig in 1,000, right? Because it's the 1.
Well, there's a decimal there, so we're gonna count these.
Oh, I didn't see the decimal. Sorry.
It's okay. That's what I
Never
figured. A couple of you guys wrote in the chat, and that's what I figured you didn't see, that the, so this 1,000 has a decimal behind it. So yeah, it might just look like a period to you, but there's 4 sig figs in this number. It's not just one.
No, yeah, I see it now.
Okay.
My bad.
Okay. All right. Did I answer your question? I think so. All right. So let's go to number 3. Oh, wait, is this an endothermic or exothermic process?
Endothermic.
Endo.
All right, we get that. All right. Let's do number 3. Number 3 says if the temperature of 34.4 grams of ethanol increases from this to this, how much heat has been absorbed by the ethanol? So heat, what are we looking for? What letter?
Q.
Q.
Q. We're looking for Q. Q equals MC delta T. It says that the heat has been absorbed. Is this an endothermic or exothermic process?
Endo.
Endo.
We already know it's endo because it just tells us. All right, so in this case, what's my mass?
34.4.
34.4 grams. What's my specific heat capacity?
2.44.
It says 2.44 joules per gram degree Celsius. And then my change in temperature is what, guys?
53.8.
Well, I'm gonna write the finals 78.8 minus the initial. Looks like this. Here we are. This is the setup. Did we at least get this set up, guys?
Yes.
Yeah.
All right.
Yes.
All right, so let's go through the steps. The sig fig seems to be throwing you guys off. If we subtract these two, what's the rule here?
Least amount of decimals.
What's the least amount of decimals?
None.
One decimal.
No decimals.
I mean
20
0. I'm sorry.
Okay, so 78.8 minus 25 is what, guys? Let's see. I heard somebody say it, but I forgot.
53.8.
All right, 53.8, but we know it's no decimal, so just remember that it stops right here at 53. There's no decimal.
Oh,
No, it's supposed to be 54 because the number after the decimal is 8. It's 53.8.
Oh, sorry, not 53.4, thank you. 53.8. All right, so 53.8, but we only want 0 decimals, so I'm stopping the number really here at 53, but we're not gonna round into the end. So can anyone tell me how many significant figures I should have in my answer?
2.
2. We see that it's 2 sig figs because this number technically only has 2 sig figs. So I'm gonna say this number times, what's that, 34.4 times 2.44. Did you guys get this in your calculator?
Yes.
I get 4448.
Well, look back again and see if you typed everything in correctly. And then if I round this number to 2 sig figs, someone help me round this to 2 sig figs. What should it be?
45.
45.
4.5 times 10 to the third.
4.5 times 10 to the third, or we can say what?
4,500?
4,500. I still hear people saying 45, guys. You're gonna get all your questions wrong on the quiz on Wednesday by not recognizing how to round your sig figs. If you say 1, 2, yes, that's 45, but you have to account for these spaces over here. You can't just ignore the 1 and 5. We're rounding it up or rounding it down. In this case, there's a 1, so we're gonna round it down to 0. So it's 4,500. Or we can say 4.5 times 10 to the power of 3. And this is gonna be,
So either way, Ms. Page, it'll be right on the quiz. If we put
yeah.
4,
So, unless the question says, write your answer in scientific notation.
okay.
So either way should be correct, but it's gonna be multiple choice, a lot of it, so you should just see your answer.
Okay.
45 might be one of the answers, so we're not rounding your sig figs for it, so you're gonna write down the wrong answer or click the wrong answer.
Mhm.
All right. Okay. You guys want to do one more, or you think we can stop here and start talking about the lab?
Oh, we can do one more.
Want to do one more? Let's do one more. Let's try to do this one a little quicker. I'll give you guys a minute or two to try to figure this out on your own. right, give me a thumbs up if you guys got this. Okay, cool. All right, let's talk through it. We have graphite, which is just carbon. It has a specific heat of this number. If a 25-gram piece of graphite is cooled from 35 to 18 degrees, how much energy was lost by the graphite? So first off, guys, tell me, is this an endothermic or exothermic?
Exothermic.
Exothermic.
It's exothermic because we're losing heat or losing energy. So the question says how much energy? So in this case, what are we solving for?
Heat.
Heat,
Q.
which is
Q.
what letter?
Q.
Which is,
Joules.
once again, we're looking for Q, which is MC delta T, like this. In this case, our mass, what's our mass, guys?
25 grams.
All right, so we're gonna say we have 25 grams times C, which is what, guys?
0.709.
709, all right, great. Joules per gram degree Celsius. And then our change in temperature, we're gonna say what it is,
35. 18, sorry.
minus 35. So notice the difference. This time our temperature went down. So because our temperature decreased, that's why you're gonna end up with a negative number. You're gonna end up losing heat when your temperature decreases. In the other case, our temperature, what happened here? Our temperature increased, so our final is this. This is our initial, our temperature increased. In this case, our temperature decreased. You put this in our calculator. If we quickly look at it, how many sig figs do you guys think I needed my answer?
2.
2.
2. If we do 18 minus 35, that's still gonna give us 2 sig figs or 0 decimal places. 18 minus 35 is negative 17. We multiply all that together. What'd you guys get for an answer?
Negative.
Negative 301.325.
All right, so round that to 2 sig figs for me.
Would it be 3.0 times 10?
3.0 times 10 to the negative second.
Negative 3.0 times 10 to the negative 2. It is not possible for you to put this as negative 300 because that's only 1 sig fig. If we say negative 301, that's 3 sig figs. To get 2 sig figs, we have to write this number in scientific notation. So negative 3.0 times 10 to the power of 2. Remember that negative sign just means that our heat is flowing out of the system. We're losing heat. The graphite is losing heat.
So in this problem, that's the only really correct answer.
Yes.
Okay.
Yeah. And let me put the joules behind it.
Professor.
Mm-hmm.
So if we needed 3 sig figs, so it's gonna be negative 301. That's it, right?
Yeah.
All right.
Yeah. All right. So